exploration of C++ with a quick look at where it stands in a taxonomy of programming languages. It first appeared in 1985. Its creator, Bayern Stroustrup, is of course a legendary figure in computer science. C++ was a general purpose language from the start, which means that it was not meant to be only used in one specific domain. Initially, it was thought of as C with classes, that is, as an extension of the C programming language, which allowed object-oriented programming as well. This seemed as a natural add-on. It seemed a natural starting point. If you picked up from the idea of a struct in C and added in behavior in the form of methods or functions contained within the struct, then you'd pretty quickly get to the idea of objects and classes. That was then, but a lot has changed since then. C++ has probably reinvented itself more than any other major programming language. C++ today is virtually unrecognizable even for folks who worked with it as recently as 15 years ago. From its purely object-oriented early days, C++ has now evolved so that it has support for object-oriented programming, of course, but in addition, it also supports generic as well as functional programming features. And in addition to all of this, it still retains its foundations in C, which in turn means that it's great for working with low-level memory manipulation. As they say, those who don't learn from history are doomed to repeat it. Let's take a minute to understand the early history and evolution of C++. This still informs many design choices which we can see even today in the C++ programming language. Stroustrup started working on C in 1979 and added on various features such as classes, derived classes and inheritance, and strong typing. These compiler changes together were called C with classes, and then starting 1982, he began work on C++ as a successor to C with classes, and the first edition of the C++ programming language was released in 1985. The power of object-oriented programming and inheritance caused C++ to be an almost immediate hit, and C++ 2.0 was released in 1989. This included features such as multiple inheritance, abstract classes, static member functions, and the protected access modifier. The annotated C++ reference manual was published in 1990, and this became the basis for future standards in the C++ language. Over those decades and in the 90s and 2000s, C++ increasingly became a complex language, hard to learn, albeit incredibly powerful, and as a result, it became somewhat inaccessible. Java, which was launched in the 1990s, became a hit because of the abstraction which it provided to programmers who found it hard to figure out all the intricacies of C++. In the 2000s, something known as modern C++ began to catch on. This is a colloquial term, so it doesn't have a precise definition, but it broadly refers to a style of C++ programming which makes use of new language features and reduces the burden on the programmer. Modern C++ is still incredibly powerful, but it also makes a conscious effort to be easy to use. If you have an impression of C++ as an intimidating language and one that's hard or almost impossible to learn, you should be aware that this is a dated perception. It dates back to the times before modern C++ became the norm rather than the exception. This phrase first caught on after a book called Modern C++ Design, which was released in 2001, and in today's world, more than 2 decades later, the term still resonates. Modern C++ today refers to a style of C++ as well as to the associated programming language features introduced in the years since then. The C++ 11 standard probably marks the point where modern C++ took over as the dominant strain of C++. The C++ as it existed and was used before C++ 11 is these days often referred to as classical C++, or somewhat less flatteringly as legacy C++. C++ 11 and all subsequent versions and programs written in the idiom of these versions collectively are known as modern C++. The term legacy C++ itself spans a wide range of C++ standards and language features. The original standard was effectively Stroustrup's own book from 1985, and subsequently the book The Annotated C++ Reference Manual, published in 1990, took over as the de facto standard. Things became a little more formal with the launch of C++98, which defined the functionality and in many ways was the first C++ standard. This included the STL, that is, the standard template library, containers, algorithms, strings, and streams. All of these are firmly a part of legacy C++, although they were seen as very modern language features back when they were first introduced. Then, from C++98 until C++11, change was relatively slow. In the 2000s, C++ evolved fairly slowly until in 2011, the ISO, that's the International Organization for Standardization, released a new version, C++11. The general feeling before the release of C++11 was that the language was getting out of touch, too hard to use, and just not accessible to younger programmers who were drifting towards easier to use languages like Java and C Sharp. C++11 changed all that. It added in so many language features and support for so many other programming paradigms that it's realistic to think of C++11 and versions after that as an entirely different language than legacy C++. The C++11 standard effectively enshrined modern C++ and fundamentally changed the language by adding in a large number of new libraries. These included language support for regular expressions, smart pointers, hash tables, random number libraries, move semantics, a new memory model, and a threading API. The rapid change did not stop there. More features were added in C++14 and C++17. Generalized lambdas, read-writer locks, and const_expr functions were added in C++14, and then in C++17, the STL was parallelized and the standardized file system was introduced. These changes were all pretty major in and of themselves, but they were much smaller than those introduced in C++20, which again made fundamental changes to the language, further reinventing C++ after C++11. 4 major language features were added: ranges, coroutines, concepts, and modules. If you last used C++ in say 2005 or the years before that, then you would recognize that C++ is effectively an entirely different language. Ranges, which were introduced in C++20, make it a lot easier to work with containers in the STL. These have lazy algorithms which work directly on the container and can be composed. This makes them somewhat different from iterators. Coroutines are great for asynchronous programming. This includes support for functions that can suspend or resume their execution while maintaining their state. We can define the semantic categories for valid template arguments using concepts. This allows you as a developer to express your intent for the kind of template to be accepted by a class or a function. And finally, modules, which simplify the structure of header files and greatly reduce compile times, which were seen by some as becoming intolerably long in the early 2000s.